All right, we're hoping a third take allows us to fully get through this lesson. I've been interrupted a couple times on it, so my apologies if I go through something too quickly and assume that I've talked about it already. I probably have, but just not on camera. So in this lesson, we're going to look at perimeter and circumference. So just kind of a brief overview, and we're going to use some of our algebra skills in order to find out some missing numbers. Oftentimes in the trades, we don't need to find out those missing numbers. But it's something that from a math perspective is actually an important piece, is being able to take what you know and work backwards with it, okay? So we will look at a little bit of that. Now, by the end of this lesson, we should be able to calculate the perimeter of triangles, squares, rectangles, and we'll look at a formula for our trapezoids, just following some formulas, and we'll also be able to calculate the circumference of a circle. This lesson shouldn't be too long and should be just a really good reminder of how we need to calculate these components. First of all, what is perimeter? So perimeter is the distance around the outside edge of a shape. So in any of these, oops, my pen's turned off. So in any of the shapes that you see over here to the right of the screen, the black line represents, the black solid line represents our perimeter. Now the dashed lines are often information that we need to know in order to be able to calculate perimeter or area, but your solid line around the outside is perimeter. Now perimeter is always linear, meaning it could be stretched out to a single line. So if I took a rectangle, for example, I could take the four sides of a rectangle. So there's our width plus our length plus another width plus another length. I could join all three of these to make a single straight line that is equal to the perimeter. So if we added all of these together, label them just for the sake of, okay? Now you'll notice there's, for perimeter, we have a special formula. So perimeter equals 2, and then in brackets, length plus width. So really what that's looking at is it's taking what we have here and it's grouping things together and saying, well, if I take the width and the length, I'm going to have two sets that are the same, and I could write that as 2 length plus width, okay? Add the length plus just the length plus the width and then double it would give me the other side. So we're adding these two, then on a rectangle we can double it for the other side, equals perimeter, we'll call this a rectangle. Okay, if you had a square, it's just going to be 4 times the length of the side. I don't usually put a square in there because I feel like that's one that you probably already should know. We'll talk for a minute about octagon and hexagon and a couple of those shapes, but you won't see those ones very much. If we don't get to them in this lesson, it's going to be okay. Now, if you'll notice for our triangles, a triangle, we're looking at the sum of the sides. So sum just means, for those of you that miss some math words, sum means add. So we add the sides. Because the sides aren't always the same, we can't follow a formula. A trapezoid, again, we add the sides. This side and this side, they could be the same or they could be different, so we can't necessarily just follow a formula, so we need to know the length of each side, and then we're going to look at the circle separately. So to start, let's start with a rectangle question. How many feet of fence does it take to surround a rectangular compound that measures 15 feet 7 inches by 20 feet 9 inches? So we'll sketch out our rectangular shape. 15 feet 7 inches. Now I always say you should start by drawing a diagram. You could label all of the sides. I'm only going to label the 2 of them for now, because we know if that's 20 feet 9 inches and we have a rectangle, then this is also 20 feet 9 inches. And this side is 15 feet 7 inches because of what the other side is. So first, let's draw a diagram if it's not given. You'll notice these are the same steps we have in word problems. And 2, we're going to label. Label our lengths or our measurements that we know. So this is what we know. We need to find out what is the perimeter. So I often will start by writing the formula. So perimeter is 2 times the length plus the width. Now this actually makes our math a little bit easier. Sometimes people will write this as 2 lengths plus 2 widths. That's another equal question. What that would be the same as is that's the same as distributing this 2 inside. Remember that from doing our algebra. So let's fill in our information. So I'll put a little or in here just so you know you could use either one. So now let's plug in our information. So length we'll take as the longest one and we'll do our width as the shorter one. It's not really going to matter which order you put them in. So 2, our length is 20 feet, 9 inches, plus 15 feet, 7 inches. Now you have to think back to earlier before our first midterm when we took feet and inches and we added them together. So when we add feet and inches, we can keep them separate. That's perfectly acceptable, and it often makes it easier. So we have 2. We'll add the feet together. 20 feet plus 15 feet leaves me with 35 feet. 9 inches plus 7 inches leaves me with 16 inches. So we have 2 times 35 feet, 16 inches. And now what we need to do is so we've got 16 inches here. We don't like to keep 16 inches just because that's more than a foot. So we're going to change that. So I'm going to just do a little note over here. 35 feet, 16 inches. We're going to take 12 away from the 16, but in order to do that, I have to add 1 to the feet. Okay, so that leaves us with 35 plus 1 is 36 feet, and 16 inches take away 12 inches. So we moved a foot over, leaves me with 4 inches left. So this is the same as 2 times 36 feet, 4 inches. Now we have to distribute. So remember when we distributed before, so we're doubling this, so we're going to have to multiply the feet by 2 and the inches by 2. You could turn everything into inches and then convert back. That would be acceptable as well. But this is actually quite an easy way to do it, and that's because there's just one single number out here. It's not like it's feet and inches. If it was a combined unit with feet and inches, we'd be in trouble. But if we're just doubling, if we double both of them, so 2 times 36 leaves me with, 72. Sorry. I'm not sure where my mind went there for a sec. So 72 feet, and 2 times 4 inches leaves me with 8 inches. So the perimeter is 72 feet, 8 inches. So we need 72 feet, 8 inches of fence. So fence goes around the outside. So that's how we know that's a perimeter question. So label the lengths and then find the formula. And then 4, calculate. Now we will check our units as we go. This question asked how many feet. Because it asked how many feet, you could have left it in decimal feet. But because we were given feet and inches, we matched to feet and inches. If you wanted to go to whole number of feet, just because it does say feet in the question and I wasn't specific on rounding, we would have to go up to 73 feet of fence because we would need enough to fully go around. We don't want to leave any gaps. If we round down to 72, it would leave us a gap. All right, hopefully that question makes sense for you. Now the next question we're going to do is, again, we're going to be looking at perimeter. We've got a rectangle. This question is labeled as rectangle, but this time we're going to be doing some backwards. So this question tells us the perimeter of a rectangular shape is 145 inches. If the width is 23 inches, what is the length of the rectangle? And then answer in inches. So this question tells us the perimeter, and I like to pull the information out first. Perimeter is 145. We know the width is 23 and the length is what we're looking for. So there's my lengths, and this is 23 and this is 23. Now we need to pull out, we've got a diagram drawn, we've labeled our lengths. Let's find out what our formula is. So we're dealing with a rectangle, so here's our perimeter formula. We need the perimeter formula because we're told the perimeter. I'm told the perimeter, I know this, and I'm looking for length, but I know the width. So there's only one letter that we don't know. So we're going to write our formula down and then we're going to fill it out. So the perimeter is 145 inches. You always want to make sure your units all match that you put in. If you put inches in for perimeter, we need to put inches in for length and width. Times 2, our length is what we don't know, so we'll put an L in, and our width is 23. Now the reason I'm using L and not X is because that will remind me what I calculated. I like to use letters that represent words because then when I get to the end of the question, I'm not going, oh, what in the heck did I say X was? So now that we have this, we need to get rid of our brackets. So there's two ways we can do this. We can either bring the 2 in, or we can divide the 2 out to the other side. Two methods. I think we did both ways when we were looking at it in our last lesson. So what I've decided to do for this one is I've decided, well, it's 2 times what's in the bracket. So let's divide by 2. That'll cancel this out. And whatever we do to one side, we do to the other. So 145 divided by 2 leaves us with 72.5 inches equals, and now we don't have to keep the brackets because we got rid of the 2 that's in front, length plus the width of 23 inches. Now we're down to a really simple algebra question like you've had before. Subtract 23 inches. And this goes to 0. 23, take away 23, leaves me with 0. So I have length. And 72, take away 23, leaves me with 49.5 inches. So not overly complicated. Easy enough to figure out. So basically what we've done here is when we divide this perimeter by 2, we find out half the perimeter. Half the perimeter is just these 2 sides. So here we get half the perimeter. So it's half the perimeter, 72.5. That's the same as the length plus the width. And then just subtract off the one piece that you know. We could use logic to figure that out, but we can also use our formulas to figure that out since you've done your algebra component. Now we want to look at a combined rectangle. We won't do many combined shapes, but I will throw in just a couple for you to refresh. So we want to find the perimeter of the following shape in, oops, it says square inches. It should just be inches. I actually edited this question. So in inches, take the square out for me. I'll edit that before I upload your slides. Given the following measurements, so H equals 1 foot, B equals 8, and T equals 2 inches, and everything is labeled in our diagram. So we have a diagram, so we don't have to draw it, but we should put our measurements in. So H equals 1 foot. Well, you'll notice we want inches at the end, so let's change our units to inches at the beginning. So 1 foot is 12 inches. So we're going to put this as 12 inches. B is equal to 8 inches. T is 2 inches. And over here we've got 2 inches. Now if we want the perimeter, we need to go all the way around. We don't want to include the line that would be here if we split this up into rectangles. So we need to figure out, well, what is the length of this side? Well, I have 12 inches here. 2 inches here that I'm not including, so that leaves me with 10 inches. On this side, we need to know what's the length of this side. Well, we can calculate that. It's 8 inches all the way across, minus 2 inches in here, leaves me with 6 inches. And now we just remember that perimeter is the sum of the sides. There's no formula we can use for this one because it's what's called an irregular shape because we've combined 2 rectangles. So the perimeter is 12 plus 2 plus 10 plus 6 plus 2 plus 8. 12 and 2 gives me 14. So just adding all of them together, I tend to group things together. So I'll show you how mental math-wise I do it. I'll combine these two. So that's 14. These two are 10. And these two are 16. 14 and 16 is 30. 14 and 16 is 30, plus 10 more leaves me with 40 inches. I should double check that just to make sure. So our perimeter is equal to 40 inches. All right, so pretty straightforward calculation. There is a shortcut for some of those L-shaped figures, but I'm going to leave that out for now, especially since for your class, you won't have to use as much as if you were the carpenter class. All right, now let's look at a couple of other shapes that are very easy, again, to do. We want to find the perimeter in meters for each of these. And in order to do that, we need to, well, check and see, is there a formula? So here, perimeter is just the sum of the sides, so we're just adding the sides together. Now, one of the key things to watch for here is this one gives us this dashed line in the middle. We don't need this. That's not perimeter. If we were calculating area, I would need that number. Same thing, this 8 in the middle, that's not the perimeter. The perimeter is the dark black line, so we only want to include that one. So here we just want to add all of our sides together. So 22.2 plus 29.8 plus 24.3 equals, adding all of those together, we get 76.3. What units are we in? Well, we put centimeters in, so this is in centimeters. How do I convert that to meters? Well, to go from centimeters to meters, we have 1 meter is 100 centimeters. So we're dividing by 100. That's 0.763 meters. So that's the perimeter. This one, same scenario. Now for this question, you could make things a little easier if you want. You'll notice there's a 7 centimeters here and a 7 centimeters here. We could combine those two if you wanted to right at the beginning. But really what we're doing is we're adding all the sides. So 10 plus 20 plus 7 plus 7. These two are 14. So 10 plus 20 is 30. Plus 14 leaves us with 44 centimeters, but it wanted meters, so we have to convert it. 1 meter is 100 centimeters. So this is on the bottom, so it's a divide. So 0.44 meters. Now, when we are doing perimeter, it's really easy to convert your units at the end. So you can wait till the end to convert. Oftentimes that makes it easier than converting 3 or 4 measurements. Now let's talk for a minute about circles. So circles are really easy to work with, but people often make mistakes with them just because they forget a couple of really simple things. So the first thing we need to think about is some circle-specific language. So the first term we're going to look at is radius. Radius is the distance from the center of a circle to the outside edge. So that's our radius. You will find the radius is used in a lot of formulas. I'm going to expect you to know these terms for your next lesson when we look at areas. I'm not going to review them again, so make sure you know what radius is. Radius is from the middle to the outside. Diameter divides the circle into two sections. So radius doesn't divide the circle, right? It doesn't cut it in half. It just goes from the middle to the outside. Diameter is like cutting or dividing the circle into two sections, goes right through the middle. So that might help you remember which one is from the middle to the outside and which one cuts it in half. Just using a little bit of wordplay there. So it's a distance edge to edge. It always will go through the middle. Now, if you look at this, two radiuses. So let me see, this pen is acting up on me a little bit. I'm going to change the color. So if I start here from the middle and go to the outside edge, there's radius 1. And if I go to the middle and go to the outside edge here, there's another radius. So diameter is equal to 2 radii. Or 2 times the radius. Okay, so we'll often see diameter equals 2r, or r is diameter divided by 2. So 2 different ways to think of it. Now, thinking about those relationships is going to be important for us because we'll often go back and forth. And then circumference is just the perimeter of a circle, so it's going around the outside edge. And in order to calculate that, we need to use, so this, I've used P here, we could also say C, circumference or a perimeter of a circle, is 2 times pi times the radius. Or since 2 radiuses make a diameter, we can get rid of the 2 and just do pi times diameter. So these are our 2 formulas for circumference. Now, what is pi? Pi, as much as I wish it was apple, is not apple pie. Pi is a number that was, I forget which Greek mathematician discovered it, some dude in a bathtub probably, because that's usually how it worked. They'd go down for the bath, and for some reason that engaged their math brain. So if you get stuck on math, maybe try having a bath. Pi, we write this Greek letter. It's like 2 little lines with a squiggle on top. There has been, it's never happened to me. The other math teacher told me about a student that consistently wrote pi by drawing a cherry pie. You know, the kind with the lattice on top? Yeah, they would draw pi every time. I prefer you didn't draw pi. If you're going to write pi for calculating circles, give me the Greek letter, so 2 little lines with a squiggle on top. You don't have to get too fancy with it. That's pi. It is equal to 3.1416. It actually goes on for infinity. It never, ever, ever stops. But 3.1416 is as exact as we will use. Sometimes people use 3.14, which is not going to be quite as exact. For the purposes of using the computer system SAM, I'm going to ask that you use 3.1416. You can also use the pi button on your calculator. Now, depending on the calculator, you may have to press shift if you don't see a button with that pi symbol as one of the main keys. If you can't find pi on your calculator, please check in with me. Now, for the calculators that have been recommended, but I know lots of people are using their own calculators, so it's really hard to predict which calculator you're using. But for the calculator I use, I have to do shift, and then it's the EXP button down at the bottom here. But most of your calculators, I think the other calculator that was recommended for the course, it's down, the pi button is down at the bottom as well. So if it's like a white key, like this, it's written right on the keys, you don't have to press shift. If it's written just above the keys, you'll want to press shift before you use it. So it's pretty easy to find, but that's going to give you the exact number. And if I press pi in my calculator, it's 3.14159264, and it would continue past that. So it's going to give us a really, really accurate number. So just see if you can find it in your calculator. Otherwise, just remember 3.1416, and which is often what I use. And you can punch that number in. All right, let's do a couple of calculations. We want to calculate the circumference for each circle. So first of all, and we're going to leave it at the units that we're given here. We're not going to bother changing our units. We'll give the answer in the units that are listed. That'll make it easy for us. So here we have a radius is 20 centimeters. So radius means I'm going from the middle to the outside edge. So that means I need to find the formula that uses radius. So we're looking at circumference of a circle, so we're down here. So we're going to use this 2 pi r. So circumference is equal to 2 pi r. R is our radius, so 2 times 3.1416 times our radius of 220. Now if we put centimeters in, we will get centimeters out. If you put that in your calculator, you will get 1382 centimeters. If you're using the pi button or you're not sure if you're using it correctly, try using the pi button instead of typing in 3.14 and see if you get the same answer. You could be out by a decimal place, but it should round off to about the same. Next one, we have a radius of 3 feet 3 inches. Now this one I've included because when we do our formulas, we have the same formula, circumference is 2 pi r. We can't put 3 feet 3 inches in for pi. We have to convert that 3 feet 3 inches into something else. So I'm going to say let's go to all inches. 3 feet 3 inches is 36 inches plus 3 inches is 39 inches. So let's go ahead and put that into our formula. So 2 times 3.1416 times 39 inches. If you put all of that in your calculator, we are going to get 245 inches, and we'll just round to whole inches. It's good enough for this section. So our circumference is 245 inches. If you would like to convert that back to feet and inches, we could do that. So 245 inches divided by 12 leaves me with 20 feet. And then 0.4 of a foot and 5 inches. Okay, so if you want to convert it back, you could convert it back. So all I did was I divided this by 12, told me I had 20 feet. 20 times 12 is 240. So subtract 240 and that leaves us with 5 inches left over. So that's where 5 comes from. All right, the very last one, I have 1.25 inches for a diameter, and we want to figure out what is the circumference. Now we have to think, we have diameter. If you were memorizing formulas and you only want to memorize one formula, you'll have to make sure you know the difference between diameter and circumference. If we have diameter, it's just pi times diameter. We don't have to do the multiply by 2 because we don't have half of a diameter. Okay, so a radius is only half the diameter, so we have to double it. But pi, but when we use diameter, we just get to do pi times diameter. So circumference is pi d, which is equal to 3.1416 times our diameter of 1.25. This time we have decimals, so we will keep decimals for our answer. You'll notice the other ones, it was a whole inches, that's why I kind of kept it the same. This one we have 2 decimal places, so it would probably be wise to keep our answer in 2 decimal places as well. At least 1 decimal place, we'll say that. So when we calculate this one, putting all of that information in, you get 3.927 inches, which if we keep 2 decimal places to match our original answer, 3.93 inches is the circumference. Okay, so it's just pulling out which formula to use. If you know if you've got a list of the formulas, it's really not too bad to find, but you watch for those key words. Diameter or radius will always mean you have a circle, even though the question might not say circle. Rectangles don't have diameters or radiuses. Triangles don't have diameters or radiuses, and neither do trapezoids. A circle has a circumference of 26 millimeters. What is the radius of the circle? So this time, let's draw our picture. So we know the circumference. The circumference is 26 millimeters. We want to know what is the distance, the radius, what's the difference from the middle to the outside. So circumference is 26. Radius, I don't know. So this is one where we're going to have to work backwards. So let's start with our formula. How are circumference and radius connected? Well, circumference or perimeter is 2 pi times the radius. I know what the circumference is, so we can fill that in. So 26 equals 2 times 3.1416 times the radius. Now we can combine these two right at the beginning. So let's do that. 26 is equal to 6.2832 times r. We need r by itself. To get r by itself, it's 6 times r, so we're going to divide. And that's where that good old algebra practice came in. Divide both sides. R is equal to 26 divided by 6.2832 leaves us with 4.14 millimeters. And you could probably argue just 4.1 if you wanted to, since we have 2 digits in what was given to you and no decimals there. So you could argue the decimal places a little bit. All right. So not too complicated. I think I have one more example for you for circles, and then we'll pause. Determine the circumference of a wire spool that has a core diameter of 1 feet 6 inches in feet. 1 feet 6 inches is how many feet? You shouldn't have to think about it. It's not 1.6. 6 inches is half of a foot. This is 1.5 feet. If you are unsure, take your inches and divide it by 12 and then add the feet onto it. So that's 1.5 feet. We want to find the circumference, and this is a diameter. Circumference is what I'm looking for. I have a diameter of 1.5 feet. That means I need to use this formula. Perimeter or circumference, I'm going to use a C instead. So circumference is equal to pi times 1.5 is equal to 3.1416 times 1.5 leaves me with 4.7 feet. If you want to put that back to feet and inches to kind of match the beginning one, that would be the same as 4 feet, and I'll round it to whole inches, 4 feet and 9 inches. 4 feet 8.5, 4 feet 9 is close enough. How many feet of wire are in 10 wraps? Well, 4.7 feet times 10, we got 10 wraps, so going around 10 times, leave with 47 feet. So pretty straightforward questions. Hopefully that gives you a good overview. The only thing we didn't talk about was how many sides does an octagon or a hexagon have? Octagon has 8 sides. Think of an octopus has 8 legs. Hexagon, 6 sides. So those are regular shapes that if they all have the same length of side, you could just multiply by how many sides there are in order to figure them out. But I know those ones are pretty common. You'll see a couple questions with those, but we'll give you a reminder for how many sides. We will take a brief pause, and then we will, in the next video, we're going to look at calculating area.